Welcome back. In this class, we are going to discuss the difference operation on two different regular languages, or you can say two different automatas. So in the previous class, we have discussed how to apply union operation or intersection operation on two automatas or regular languages. Now today, we discuss the difference. So just quickly recall what we have discussed in the previous class. There are two automatas. Those are accepting or generating two regular languages. So A1 is one of the automata, A2 is one of the another automata. A1 is accepting such kind of language in which every string is having even number of zeros. And A2 is another automata which is accepting a language where every string need to have odd number of, or the ones must be in the multiple of 3, right? So either 0, 3, 6, 9 and so on. Okay. So if we want to represent, let's say A1, so there is A1 is accepting, let's say language 1, we can write, you find out in many of the books, the number of zeros in every W means a string, there is, I'm saying, congruent to 0 mod 2. So 2 I can write like this. So that means whatever the number of zeros will occur in every string of language L1, which is represented by automata A1, this must satisfy this particular relation. Okay, so that means the number of zeros must be in the multiple of 2, right? So similarly, we can represent L2 language, which is being represented by A2 automata. So here you can write the number of ones in every string W in L1 need to be in congruence with 0 mod 3. So in this way also we can represent these two languages. Now if these two languages are given, okay, we are already aware about, we have drawn that the automata A1 will have 2 states and automata A2 will have 3 states, and if you combine these two automatas, the total number of states will be 2 cross 2, that is 6. So that has been drawn. Now this particular transition diagram will be same whatever the operation you will perform, whether you are performing union, intersection or difference. The only changes which you need to make in this diagram, you need to make the changes in final states. So initial state is also fixed, where the combination of initial states of both the automata will be there, that will treat as the initial state of this automata, right? So in case of union, when you are combining these A, B with X, Y, Z, whatever the number of states you have, so here we are having, let's say, AX, AY, AZ, BX, BY, BZ. Now here A is the final one. So in case of union, I'm saying in case of union, wherever final states either from A1 or A2 comes, it will become the final state. So AX will become the final state because A is the final one, X is also the final state in this automata. This will also be final because A is the final, Y is non-final, that's okay. This will also be final, right? In this, B and Y both are non-final states, so this will not become final. BX, right? BX will become final because X is the final state, but B is not, so this will become final. But BY and BZ will not be the final because in this automata B is non-final, in this automata Y and Z both are non-final. So this is related to union. If we do the intersection, in that case, the final state will be only one, wherever if you are combining two states, both the states need to be final. So in A1, A is the final one, in A2, X is the final. So wherever A and X you are combining, that will become the final state. So that is intersection. Okay. Final state will be having the both state as final state. Now let's discuss the difference. So if we are calculating difference, the difference is altogether a different mechanism. There are two types of differences we can create or calculate. So the very first difference we can say, let's say A1 difference A2. That means all these strings, those can be accepted by A1, but can't be accepted by A2, need to be generated. Okay. So in this case, all such combinations of A and like AX, AY, AZ will become the final, where the final state of A2 is not involved. So here, if I consider AX, X is the final state in A2. So this will not become the final state. Okay. But AY will become the final state because A is the final state of A1. AZ will become the final state. Right? So these two will be the final state. AX will be initial state, but it will not be the final state. In case you are trying to find out A1 difference A2. I hope you are clear, right? Now let's discuss A2 difference A1. So if we are calculating A2 difference A1, then the meaning is almost similar. All these strings, those are accepted by A2, but not accepted by A1, will be the part of this language, the resultant language, right? So that means all the states, those are having the final state of A2. All the states like X is the final state of A2. So here it is, here it is. There are two states. So these two can be final, but make sure that the final state of A1 should not be the part of. So this AX will not be the final state, because if we make the AX as the final state, few of these strings which will be accepted by A1 will also be accepted by the resultant automata. So only one final state we will get, that is BX. Okay, right? So BX will be the final state in case of you are generating or performing operation A2 minus A1. The transactions will be same, which we have already drawn. So I'm not drawing it again. Just you need to update the final states and you will get the difference of two automatas. Okay. So I hope the union, intersection and difference operations are clear. So in case two automatas are given, you can easily draw the resultant automata and you can find out the resultant language. Okay. So thank you. I'm closing this session. See you in the next class.